Direct and inverse variation notes. First, let's take a look at direct variation. With direct variation, we have the terminology, the vocabulary, y varies directly as x. So anytime you see varies directly, you have a direct variation. So y varies directly as x if there is some non-zero constant k, non-zero, it's a constant, k such that y equals k times x. K is called the constant of variation. So you may know it as the slope of a line, y equals mx plus b, y equals kx. So to find that constant of variation, that's the first thing we want to do anytime we're solving a problem where direct variation is involved. So let's take a look at the problem. It says here that y varies directly as x. So right away, when you read that, okay, you should automatically think this. Okay, we got that up here. The next thing we want to do is, after we've written this down, is we want to solve for k. So to solve for k, we need to plug in a value in for y and in for x. So they give us a y value, and they give us an x value. So solving this for k, we divide by 5 on both sides. So in this case, k equals -3. Notice it fits the definition. K is a non-zero constant. Okay? Now that we know what k is, what we do is we plug it in here. So our equation is going to be y equals -3x. Now that we know the equation, we can solve the problem. It says find y when x equals 3. Okay, so find y when x equals 3. So we plug 3 in for x, and so y equals -9. Remember, we have to solve for k first. Then we have to write the equation, and then we actually solve the problem that's given to us. Okay, another type of variation is an inverse variation. Here, the terminology or the vocabulary goes like this. Y varies inversely as x if there is some non-zero constant k such that y equals k over x, where x cannot be equal to 0 and y does not equal 0. Okay, so here we go. If r varies inversely as t, okay, so there's your terminology. That tells us y equals, that says that r varies inversely as t. Okay, so we're actually using r and t instead of y and x. So r varies inversely as t. And you notice up here it says y varies inversely as x. So y went first, and then x went underneath, and your constant goes on top. So here r goes first, okay, t goes on the bottom with your constant on top. So do you remember the first step? That's right, we need to solve for k. Okay, so plugging in the numbers they give us that r is equal to -6 and t is equal to 2. And we want to solve for k. So we're going to multiply both sides by 2. So k equals -12. Okay, now that we know the constant of variation, we plug it into our equation. So R equals negative 12 over T. Okay, now we answer the question. It says find R when T equals negative 7. So R equals negative 12 over negative 7. So R is going to be 12/7. Now let's back up for a moment. It says if y increases, what happens to x? So I want you to think about that in this problem. As y increases, what happens to x? Again, if y decreases, what happens to x? What happens to this number? So I want you to think about that and see if you can come up with a conclusion on your own. Okay? Same thing. For an inverse variation, if y increases, what happens to x? Very important. If y decreases, what happens to x? So see if you can figure out the relationship. Let's do a couple more notes here. If I give you, say, a problem like this, m times n equals 6, and I ask you, is this a inverse or a direct variation? Well, it's kind of hard to tell, because remember, direct is y equals kx. That's the basic form. Inverse, y equals k over x. Well, our two variables here are on the same side. So what you have to do is you have to solve for one of the variables. M or n, it does not matter. Let's go ahead and solve for m. So if I solve for m, I'm going to divide by n. So we have m equals 6 over n. So what does that look like? That's right. It looks like the inverse variation. It is an inverse variation. At first glance, you may have thought it was direct because of the multiplying. But you have to get the letter by itself to know. So this is inverse. And we would say that m varies inversely as n. And there's the words I'm using. M varies inversely as n. Okay, let's do another example. Let's say we have C over P equals 4. Okay, well, it's not completely clear if it's direct or if it's inverse. You may have a tendency to think inverse because of the division, but it may not be. Remember, what did we have to do? We had to get the variable by itself, correct? So the same thing here. Let's get the variable by itself. Well, which one? It doesn't matter. I think I'm going to go ahead and solve for C. So if I solve for C, I'm going to multiply both sides by P. And so C varies directly as P. So this is actually direct, a direct variation. And this one was inverse. Okay, a couple more quick examples. Some straightforward ones. Let's say we have, say, f equals negative 7/3 g. What do you think that is? Correct. That's direct. Okay, matches the form. Okay, constant of variation is k. Constant of variation here is 4. Constant of variation up here is 6. Okay, I think you got it. We're at 10 minutes anyway, so I'm going to stop here. Hope you all are having a good night.